Luftwaffe controllers in Pas-de-Calais dispatch over 1,000 aircraft toward London. Hermann Göring predicts the RAF will collapse within 48 hours. Yet before the German formations cross the Channel, radar operators at Dover and Forness have already plotted their bearing, altitude, and strength. Within minutes, sector controllers at Uxbridge vector 11 group fighters into position. By day's end, 56 German aircraft lie scattered across southern England. Only 26 RAF machines are lost. This single day becomes the operational proof of an invisible network. 350-foot towers and cathode ray screens. Germany's defeat began not in the clouds, but on radio frequencies between 20 and 30 megahertz. These signals, first dismissed as impossible physics, would cancel Operation Sea Lion and change the course of air warfare forever. An oscilloscope trace brightens and falls in a shed outside the BBC transmitter station. A Hanley Page Hayford bomber passes overhead at 8 miles away. The returning radio echo registers on the screen. A junior engineer enters notes in a logbook. The wavelength, 49 meters. The time, 1430 hours. The temperature, 4 degrees Celsius. Physicist Robert Watson-Watt stands beside the equipment, watching the trace repeat with each pass of the bomber. Air Vice Marshal Hugh Dowding observes from the doorway, arms crossed, expression neutral. The demonstration lasts 17 minutes. The bomber makes 4 passes. Each pass produces a clear return signal. Each signal confirms the principle. The conclusion arrives immediately. Aircraft reflect radio waves at tactically useful ranges. Not theoretical, not marginal, tactically useful. The Air Ministry had expected radio detection to identify thunderstorms, not aircraft. Storm clouds produce electrical disturbances. Lightning generates radio noise. Meteorologists wanted a tool to track weather systems. Watson-Watt and his assistant Arnold Wilkins, called Skip by colleagues, prove radio waves detect solid objects equally well. The BBC shortwave transmitter, operating at 49 meters wavelength, illuminates the bomber clearly enough to track bearing and distance. The signal bounces off the metal fuselage and returns to a receiver array. The oscilloscope displays the time delay. Time delay equals distance. Direction-finding techniques provide bearing. Together, position. Dowding asks technical questions. Range limitations. Accuracy tolerances. Weather effects. Interference sources. Watson-Watt provides measured answers. The physicist understands this audience. Military officers need operational capabilities, not theoretical possibilities. Within 6 months, the Air Ministry issued a directive. Funding authorized, £10 million over 4 years, less than 2% of annual defense spending. The project receives a designation, Air Ministry Experimental Station, MES. The location, Bawdsey Manor on the Suffolk coast. A Victorian estate converted to a radio laboratory. Early trials at Bawdsey Manor show reliable detection beyond 8 miles. Then 12. Then 20. Improvements follow rapidly. Higher peak power from transmitters. Taller masts elevating antennas. Better receiver design reducing noise. Improved oscilloscopes displaying clearer traces. By 1937, detection ranges exceed 60 miles. By 1938, 120 miles. A 10-fold improvement over the original Daventry test. Achieved through systematic engineering rather than revolutionary breakthrough. Incremental gains. Persistent refinement. Disciplined testing. An early memorandum to the Director of Scientific Research records the conclusion in measured bureaucratic language. Detection feasible at tactically useful ranges. Integration to command structure is essential. The phrasing understates the revolution. For the first time in military history, defenders can detect attackers beyond visual range, beyond sound range, beyond any human sense. Radio waves provide early warning measured in minutes, not seconds. The proof moves radar from laboratory curiosity to national defense requirement. Physics becomes linked to air defense doctrine. The technology exists. The question becomes, can it be scaled into a network covering the entire coast? Can detection be integrated with command and control? Can warning be translated into interception? The answer will determine whether Britain survives the coming war, whether Churchill's island can hold against continental power, whether democracy can resist totalitarian assault. By 1938, the same principle demonstrated at Daventry maps targets out to 120 miles. A capability no adversary anticipates. A system no enemy yet understands. A weapon invisible to reconnaissance. A defense built on electromagnetic spectrum rather than concrete and steel. The towers begin rising along the coast. Steel lattice structures 350 feet tall, visible for miles. Yet their true function remains obscure to foreign observers. German intelligence photographs the structures. Analysts speculate about navigation aids. Radio beacons for merchant shipping. Experimental broadcasting stations. The correct answer, early warning system for air defense, appears in no intelligence assessment. Britain builds its defense in plain sight, and the enemy does not see. Along the Suffolk coastline, lattice towers rise above concrete transmitter huts. Each tower stands 350 feet high. Guy wires anchor the structures against wind loads. At the base, brick buildings house transmitters, receivers, operators, and support equipment. Inside the huts, operators perform warm-up sequences at dawn. Vacuum tubes heat according to manufacturer specifications. Oscillators stabilize. Calibrations proceed according to written procedure. Logbooks record system status every 30 minutes. Britain declares war on Germany at 1100 hours. Neville Chamberlain's voice broadcasts across the nation. Air raid sirens sound in London as a test. The population expects immediate bombing. The bombers do not come. Not yet. At that moment, 20 chain home stations are operational. Each transmits 350 kilowatts peak power. Operating wavelength, 12 to 13 meters. Pulse repetition frequency, 25 Hz initially, later increased to 50. Coastal coverage extends from the Isle of Wight northward to the Firth of Forth. Nearly 400 miles of coastline under continuous surveillance. The stations form a defensive line, a radio fence along Britain's eastern approaches. But detection alone achieves nothing. A radar contact provides position and bearing. It does not provide interception. The breakthrough lies in integration rather than detection. Chain home stations connect to Fighter Command headquarters at Bentley Priory through underground landlines. Telephone cables buried 6 feet deep, protected from bombing. From Bentley Priory, information flows to group headquarters. For groups, divide responsibility for British airspace. From groups to sectors. 7 sectors in 11 group alone. From sectors to airfields. From airfields to squadrons. From squadrons to individual flights. The system architect is Air Chief Marshal Hugh Dowding, Commander-in-Chief of Fighter Command. Appointed 1936. Dowding demands more than radar. He demands a system. Detection, filtering, tracking, control, and interception must function as one continuous process. A chain of information flowing from the coastal station to the cockpit in minutes. Dowding's background shapes his approach. Royal Flying Corps pilot in the Great War. Engineering degree before military service. Staff positions between wars. He understands both technical systems and operational requirements. The combination proves essential. Pre-war air defense planners assumed fighters would always arrive too late. Bombers travel at 200 miles per hour. Visual detection provides minutes of warning at best. Standing patrols consume fuel and pilot endurance without guaranteeing contact. Fighters exhaust themselves searching empty sky while bombers strike elsewhere. The Dowding system seeks the opposite. Fighters airborne only when needed. Directed to specific coordinates. Guided to intercept altitude before visual contact. Fuel conservation. Pilot preservation. Maximum effect from minimum resources. Economy of force as operational principle. The Royal Observer Corps fills the radar's gaps. Chain home struggles below 5,000 feet. Ground clutter obscures low-altitude targets. The Observer Corps deploys 30,000 volunteers to 1,500 posts across Britain, equipped with binoculars, sound locators, and telephones. Each post reports aircraft sightings to sector operations rooms. The two systems overlap. Together, they provide continuous coverage from sea level to 40,000 feet. An Air Ministry planning paper describes chain home in bureaucratic language, a warning and control system linking detection to economy of force. The phrase understates the revolution. For the first time in history, a nation possesses a real-time air picture. Raid strength, bearing, altitude, and speed appear on plotting tables before enemy aircraft reach the coast. Controllers can launch fighters with sufficient time to climb to altitude, vector them to intercept bearing, position them with altitude advantage, all before visual contact. Many Allied nations possess radar in 1939. France develops early warning sets. The Netherlands experiments with detection equipment. The United States Navy tests shipborne radar. None integrate sensors into national command structure. None connect detection to centralized control. None translate information into operational advantage. Germany fields capable sets for gun laying and local warning. Freya provides early warning for anti-aircraft batteries. Würzburg directs heavy flak with precision. Both systems demonstrate excellent engineering. But German doctrine treats radar as an isolated sensor, not the foundation of coordinated defense. Each battery protects itself. No national network exists. No centralized control-coordinated response. Britain chooses a different path. Invest less in sensor performance. Invest more in network integration. Accept limitations in bearing accuracy. Compensate through centralized filtering. Build system rather than collection of independent stations. On the day Britain declares war, its first national air picture is already forming. Quietly, continuously, and in time. The operators watch cathode ray tubes. The plotters move wooden markers. The controllers issue preparatory orders. The system functions through peacetime drills. When war comes, the procedures already exist. The towers stand ready. The cables carry signals. And the nation prepares to test whether information can defeat numbers. In the filter room, wooden counters move across a glass plotting table under the hands of Women's Auxiliary Air Force personnel. Colored lamps mark track updates. Red for hostile, blue for friendly, yellow for uncertain. Telephone headsets carry bearings from coastal stations. Voices report range, bearing, estimated strength, and altitude. Plotters update positions every 30 seconds according to standard procedure. The room operates in shifts. 24 hours per day, 7 days per week. Each coastal radar station reports raw data directly to Bentley Priory. Multiple stations detect the same formation from different angles. Bearings intersect. Triangulation provides position. The filter room's task: convert multiple raw reports into a single verified track. Filtering separates signal from noise. Bird flocks produce radar returns. Weather phenomena generate false contacts. Equipment malfunctions create ghost tracks. Experienced filters recognize patterns. Real aircraft tracks maintain consistent bearing and speed. False contacts behave erratically. The distinction means everything. Filtered tracks pass to the operations room 1 floor above. More plotters. More glass tables. Group controllers observe from elevated galleries. Sector controllers receive telephone updates continuously. Squadron liaison officers stand ready to relay scramble orders. The mean delay from first radar contact to sector scramble: 3 minutes 15 seconds. Measured, documented, tracked daily. Germany assumes ground observers and radio intelligence remain fragmented. Separate services, competing priorities, slow coordination. Britain proves the opposite. Detection, intelligence, and control fuse into a single workflow. Information moves from sensor to shooter in minutes. The speed makes defense possible. Without integration, early warning becomes merely early knowledge of defeat. Air Chief Marshal Dowding visits Bentley Priory daily. He reviews statistical returns in his office.
Sortie flown.
Interceptions achieved. Fuel consumed. Losses recorded by cause. Combat, accident, mechanical failure. Operational research begins to shape tactics before the term exists in formal doctrine. Doubting demands quantification. How many fighters are required per interception? What fuel margin is necessary for combat? What readiness posture balances availability against fatigue? The questions drive data collection. Data collection drives analysis. Analysis drives tactical refinement. Keith Park commands 11 Group, responsible for Southeast England and London's direct approaches. Appointed April 1940. Park understands Doubting system intimately, having helped develop it. Trafford Leigh-Mallory commands 12 Group, covering the Midlands and East Anglia. Different personalities, different tactical philosophies, but both operate within Doubting's framework. Both officers receive real-time updates from Bentley Priory. Both can request reinforcement from adjacent sectors. Group boundaries remain permeable. Resources flow toward threat. The system functions through discipline and repetition. Drill builds reflex. Reflex enables speed. Speed enables survival. Standing patrols disappear from fighter command operations. Directed interceptions replace them. Fuel conservation improves 40%. Pilot fatigue decreases proportionally. Squadrons launch only when targets approach within 70 miles. Controllers vector fighters to intercept altitude and bearing. Visual contact occurs at 10 to 15 miles, providing time for tactical positioning. Fighter command routine orders mandate daily statistical returns. Every sortie logged. Every contact is analyzed. Loss ratios calculated. Ammunition expenditure tracked. Maintenance hours recorded. The data drives adjustments in tactics, readiness states, and squadron rotation. Women's auxiliary Air Force teams receive recognition by name in duty rosters. Their timing drills reduce average reporting delays from 5 minutes to 3. The difference appears marginal. In practice, it determines engagement geometry. 3 minutes allows time for fighters to climb to 20,000 feet. 5 minutes forces engagement at 15,000, surrendering altitude advantage. Precision matters. Every second counts. Every procedure serves a purpose. Nothing left to chance or improvisation. A fighter command technical note summarizes the system in one sentence. The value lies in the net rather than the node. Individual radar stations matter less than network integrity. Individual fighters matter less than coordinated squadrons. Individual controllers matter less than standardized procedures. The whole exceeds the sum of parts through integration. Germany still calls the coastal towers navigational aids. Abwehr intelligence dismisses chain home as experimental equipment unsuitable for military operations. Reports describe limited range, poor accuracy, vulnerable to weather interference. Luftwaffe planning documents reference British radar as unreliable technology useful only for gunnery control at short range. The assessments contain fatal errors. German analysts evaluate chain home as an isolated sensor system. They miss the integration. They ignore the network. They underestimate discipline. Technical intelligence focuses on component performance. Operational intelligence should focus on system effectiveness. The distinction escapes notice. By May 1940, Britain's air defense functions like a measured machine. Inputs feed through standardized processes. The process produces predictable outputs. Predictability enables planning. Planning enables the economy. Economy enables sustainability. And the enemy still does not understand what it faces, does not see the network behind the towers, does not recognize the system behind the procedure, does not grasp that Britain has transformed detection into doctrine. The filter room plots continue moving. The controllers continue vectoring. The fighters continue scrambling. The system operates. And war approaches across the channel. The human circuit, connecting sensor to shooter through disciplined procedure, stands ready for testing under fire. Ready to prove whether organization can defeat improvisation. Whether measurement can defeat mass. Whether information can defeat numbers. The answer will be written in the skies over southern England, written in loss ratios and interception rates, written in statistics that determine survival. Luftwaffe operations boards in northern France mark takeoff times in chalk. Messerschmitt Bf-109 single-engine fighters taxi to grass strips. Engines roar at full throttle during run-up checks. Mechanics pull wheel chocks. The fighters lift off in pairs, climbing to assembly altitude. Messerschmitt Bf-110 twin-engine fighters follow. Heavier, less maneuverable, but carrying cannon armament. Intended as bomber escorts and ground attack aircraft. Heinkel HE-111 medium bombers queue behind fuel lorries. Each aircraft receives 1,200 liters. Dornier Do-17 and Junkers Ju-88 medium bombers complete the formations. Bomb loads vary by target. 500 kilograms for ships, 250 kilograms for airfields. Reichsmarschall Hermann Göring issues a directive from his headquarters at Carenhall. Destroy Fighter Command in 4 weeks. Operation Eagle Attack. Adlerangriff in German. The timetable allows 2 weeks for air superiority, 2 weeks for final preparation, and invasion in mid-August. Simple arithmetic. Overwhelming force applied with Prussian precision. The Luftwaffe assembled 2,550 aircraft for the campaign. Approximately 1,109 fighters. 1,481 bombers. The numbers represent 2/3 of German operational strength concentrated against one objective. Never before has such aerial armada assembled. German intelligence estimates RAF fighter strength at fewer than 400 serviceable aircraft. Estimates based on claimed kills during the France campaign, minus estimated production, plus estimated attrition. The mathematics appear sound. The baseline data proves incorrect. Abwehr assessments describe the British coastal masts as civil beacons, navigation aids for merchant shipping. Some reports mention radio detection but dismiss effective range as negligible, perhaps 10 to 15 kilometers maximum. Intelligence officers note the tower's visibility but cannot imagine their purpose. The concept of long-range detection network exceeds doctrinal imagination. The first day of sustained operations begins at dawn. Formations assemble over Calais and Boulogne. Controllers coordinate timing. First wave targets channel convoys. The second wave targets coastal airfields. The third wave targets aircraft factories. Chain home detects formations while still assembling over France. Operators plot bearing and strength. Filter room converts raw data into tracks. Operations room issues sector alerts. Park scrambles 11 group squadrons with 12 minutes warning. Hurricanes and Spitfires climb to 20,000 feet before German formations cross the coast. More than 60% of German raids are intercepted before reaching primary targets. The percentage astonishes Luftwaffe commanders. Pre-war exercises suggested a 30% interception rate at best. Reality exceeds expectations by a factor of 2. The day ends with approximate losses: 30 RAF aircraft destroyed versus 47 Luftwaffe aircraft. Both sides claim higher enemy losses. Combat pilots overestimate in the heat of battle. Multiple fighters attack the same bomber. Each claims to kill. Post-war records establish accurate figures through examination of unit records, crash sites, and casualty lists. A fighter command summary notes interceptions achieved by vector, not patrol radar bearings, and height calls guide fighters to contact. Fuel margins improve because fighters fly direct routes to intercept rather than searching patrol sectors. Cohesion remains intact during engagement because squadrons arrive together at planned altitude. Germany scales raids expecting system overload. More aircraft, more formations, more targets simultaneously. The logic appears sound. Every system has a capacity limit. Exceed capacity and system collapses. The opposite occurs. More targets produce clearer radar returns. Multiple formations improve bearing accuracy through triangulation. Controllers gain practice directing simultaneous interceptions. Experience builds procedural efficiency. The system strengthens under load rather than weakening. Luftwaffe planners expected the radar to fail under mass attack. Limited capacity, operator confusion, equipment breakdowns, communications overload. None materialize. The system was designed for this stress. Tested during exercises. Refined through drill. When maximum load arrives, the system performs as designed. Fighter Command rotates squadrons between forward and reserve airfields. Fresh pilots replace exhausted ones after a 4-hour duty period. Damaged aircraft transfer to repair depots within hours of landing. Replacement aircraft arrive from maintenance units the same day. The network sustains itself through measured rotation and statistical control. Nothing left to chance. Everything planned. German bomber formations suffer degraded cohesion over England. Escort fighters reach operational limits at extreme range. Fuel consumption exceeds planning estimates due to combat maneuvering. Turnaround times stretch as ground crews repair battle damage at forward bases inadequately equipped for heavy maintenance. The Luftwaffe committed to 4 weeks. After 2 weeks of operations, losses exceed projections by 20%. Fighter Command remains operational at strength. Airfields remain functional. The coastal towers still transmit. The intercepts continue. Goring increases sortie rates. The solution to unexpected resistance. More aircraft. More bombs. More pressure. Germany believes the weight of numbers will collapse the defense. Break the pilots through exhaustion. Break the aircraft through attrition. Break the system through overload. The assumption rests on false intelligence. British fighter strength never approached German estimates. Production exceeds losses. Pilot training pipeline delivers replacements faster than combat consumes them. The arithmetic of attrition favors defender, not attacker. German crews begin reporting the phenomenon in debriefs. RAF fighters appear too quickly, too accurately positioned. Controllers dismiss the reports as excuse-making. Intelligence officers note the pattern but lack explanation. The concept of radar-directed interception exists outside the doctrinal framework. Some Luftwaffe pilots theorize British fighters patrol at high altitude, diving on formations from above. Others suggest the spy network provides advance warning. The correct answer, electromagnetic detection at 120 miles range, appears in no intelligence assessment. The campaign's mathematical foundation contains fatal flaws. Germany planned an attrition strategy without an accurate baseline. When defender possesses more resources than attacker estimates, attrition favors defender by definition. When a defender detects an attacker beyond visual range, the defender chooses engagement terms. When defender coordinates through a centralized system, defender multiplies effectiveness. The assumptions prove incorrect, and incorrect assumptions determine outcomes. Stuka dive bombers from Sturzkampfgeschwader 77 roll in on Ventnor radar station, Isle of Wight. The aircraft dive at 70 degrees from 12,000 feet. Sirens scream during descent. Psychological weapon. Terror effect. 500-kilogram bombs release at 2,000 feet. Pilots pull up at crushing G-load. Explosions walk across the transmitter compound. Direct hit on one antenna mast. The structure buckles mid-height. Guy wires snap with rifle crack reports. The upper section crashes into the transmitter building. Secondary explosion from electrical equipment. Cables sever. Fragments penetrate the receiver hut roof. The building fills with dust and smoke and the smell of burned insulation. Kampfgeschwader 2 strikes radar sites at Rye and Pevensey with horizontal bombing from 15,000 feet. Formations of 18 Dornier Do-17 bombers. Each aircraft carries 4 250-kilogram bombs. Stick spacing calculated for maximum coverage. Direct hits on support buildings. Damage to receiver arrays. Power interruptions. Communication cut. For the first time since war began, visible destruction of chain home infrastructure. German reconnaissance aircraft photographed the damage that afternoon. Post-strike imagery shows collapsed masts and cratered compounds. Analysts mark photographs with annotations. Mast destroyed. Building damaged. Crater confirmed. Luftwaffe intelligence officers present the photographs at the evening briefing. Assessment: 3 stations offline. Coverage gaps confirmed. Blind sectors opened. Opportunity created. Planning staff draft follow-up strikes to exploit the advantage. Bomber crews receive congratulations. The logic appears sound. Destroy the visible infrastructure. Blind the defense. The assumption proves incorrect within hours. 3 stations sustain damage. Ventnor suffers the worst destruction. But the station returns to operation in 11 hours. Rye and Pevensey restore full capability in 6 hours. The recovery speed baffles German observers. The reason? Redundancy designed into system architecture. Chain home stations transmit overlapping beams intentionally. Coverage from Ventnor extends north into Pevensey's coverage zone. Coverage from Pevensey extends south into Ventnor's zone. 30-mile overlap standard. When one station fails, adjacent stations maintain coverage. Additional redundancy. Duplicate transmitters at each site. Primary transmitter damaged. Backup switches online. Portable generators provide emergency power when the main supply cuts. Signals depots stockpile prefabricated mass sections for rapid replacement. Repair parties arrive within 1 hour of damage assessment, equipped with vehicles, tools, and components. A signals diary entry, early afternoon. Ventnor primary transmitter offline 0840 hours. Backup transmitter online 0915 hours. System redundancy intact. Returns normal by 1400 hours. The Royal Observer Corps fills low-altitude gaps during repair. Visual sighting posts report contacts below radar coverage with less than 1 minute delay. The integrated system compensates for temporary outages through planned overlap. Nothing new. Nothing improvised. Everything anticipated during peacetime planning. Luftwaffe bomber crews report continued interceptions despite successful strikes on radar stations. Controllers still vector RAF fighters with precision. The coastal towers, though damaged, still function. Some pilots question intelligence assessments. If the stations are destroyed, why do interceptions continue? Germany spends scarce ordnance on tall targets without collapsing the network. Bombs crater compounds. Masts fall. Glass shatters. Cables burn. But the system is not blind. The coverage persists. The intercepts continue. Fighter Command signals personnel earn mentions in sector diaries for rapid restoration of service. Teams work through air raid warnings, replacing components under combat conditions. Replacement masts rise from prefabricated sections trucked from the depot. Cables reconnect through splice boxes designed for rapid field repair. Backup transmitters switch online through predetermined sequences. Repair crews train for this scenario. Drill the procedures monthly. Practice mass direction under time pressure. The investment pays immediate dividend. What German planners assumed would require weeks takes hours. Post-war analysis reveals Ventnor's 11-hour outage causes minimal operational impact. Adjacent stations at Poling and Trulee Hill maintain coverage of Ventnor's sector. Observer Corps posts report tracks below 3,000 feet with sufficient accuracy for vectoring. No undetected formations penetrate 11 group sectors during the repair window. British damage control doctrine emphasizes rapid restoration over perfect repair. Get the system functional quickly. Perform permanent repairs later during planned maintenance. The approach prioritizes operational availability over aesthetic completion. Function over form. Speed over perfection. German doctrine emphasizes thorough repair. Complete restoration to original specification before declaring system operational. The approach ensures quality but sacrifices speed. Different philosophy, different priorities, different outcome. Luftwaffe planning staff study reconnaissance photographs. Analysts measure crater patterns and debris fields. Engineers estimate repair timelines based on German standards. The estimates assume weeks for restoration. Reality delivers hours. The intelligence failure compounds. Not only did Germany misjudge radar capability, Germany misjudged British damage control effectiveness. The combination proves fatal. Strategy built on faulty intelligence produces predictable results. Failure. German reconnaissance photographs the bomb craters beside collapsed antenna towers. Interpreters annotate damage levels. Commanders approve follow-up strikes. Ordnance expended. Crews risk. Aircraft lost. All for temporary effects measured in hours. British signals personnel photograph the same sites that afternoon. Images show replacement masts rising. Cables reconnecting. Transmitters testing. Operations normal. The photographs do not appear in German intelligence files. The recovery goes undetected. The assumption of success persists. Germany believes the strikes succeeded. Britain knows they failed. The perceptual gap widens. German confidence increases based on false information. British confidence increases based on demonstrated resilience. Both sides proceed with strengthened assumptions. Only one side's assumptions match reality. The morning's bomb craters are photographed beside afternoon oscilloscope traces. Masts fall. Coverage gaps. But repair crews respond. Backup systems activate. Adjacent stations compensate. The picture reforms. The network persists. Masts fall. But the picture remains. And Fighter Command continues fighting from information advantage Germany cannot suppress through conventional bombing. Biggin Hill Sector Station shows evidence of morning raids. Burned Hawker Hurricane fighters sit in protective pens. Fabric-covered fuselages charred black. Cratered runways bear evidence of 500-kilogram bombs. Damaged hangar roofs expose twisted steel trusses. Ground crew armorers Restak ammunition belts beside undamaged aircraft as controllers call fresh squadrons to readiness state 2. Both air forces launch record sorties. Royal Air Force, 927. Luftwaffe, 1,310. The largest single-day effort of the campaign to date. More aircraft airborne simultaneously than any previous engagement in history. The sky over southern England becomes crowded with metal. German planners expect cumulative attrition to neutralize 11 Group. Repeated strikes on forward airfields. Sustained pressure on pilot reserves. Mounting aircraft losses. The mathematics favor Germany. Larger force. Shorter supply lines from French bases. More replacement aircraft in reserve. More pilots in the training pipeline. Mathematics ignores information advantage. Radar-guided interceptions limit RAF exposure while maximizing contact efficiency. Fighters launch with sufficient climb time to reach altitude before engagement. Controllers direct squadrons to specific coordinates and altitude bands. Engagements occur on British terms. Altitude advantage maintained. Fuel margins preserved. Tactical positioning optimized. Biggin Hill, Kenley, and Tangmere sectors rotate squadrons throughout the day according to Keith Park's operational policy. Exhausted units withdrew to rear airfields after 4 hours of continuous operations. Fresh squadrons move forward from reserve. Pilots rest. Aircraft refuel and rearm. Ground crews perform rapid maintenance. The network sustains fighting strength through measured replacement rather than endurance competition. Kampfgeschwader 53 and 76 press attacks against sector stations. Bomb loads fall on airfield infrastructure. Operations rooms sustain damage from near misses. Communications were temporarily disrupted when landlines cut. Ground crews restore capability within 24 hours by rerouting through backup cables and establishing radio links as temporary measures. The day's combat spread across 100 miles of front. Formations engage over the Channel.
Over Kent coastline.
Over London suburbs. Over Thames estuary. Multiple simultaneous engagements strain coordination but do not break the system. Controllers manage resources through priority assignment. High-threat formations receive multiple squadrons. Low-threat formations receive single squadron or standing patrol intercept. The day ends with losses approaching parity. Royal Air Force. Approximately 68 aircraft destroyed. Luftwaffe. Approximately 69 aircraft destroyed. Both sides report higher enemy losses based on pilot claims. Messerschmitt pilots claim 94 RAF aircraft. Hurricane and Spitfire pilots claim 144 German aircraft.
Combat inflate perception.
Multiple pilots engage the same target. Each claims destruction. Reality emerges only through post-war records examination. Post-war analysis establishes accurate figures through cross-referencing British and German unit records, pilot casualty lists, and aircraft serial number accounting. The methodology confirms near-parity losses. Neither side achieves decisive advantage through attrition this day. Radar accuracy during the engagement, plus or minus 4 miles on raid plots. Adequate for height and position vectors. Controllers direct interceptions without visual confirmation of target. Squadrons achieve contact at planned altitude in 90% of vectored engagements. The statistics demonstrate system effectiveness under maximum operational stress. Air Chief Marshal Dowding writes to air staff following the day's operations. The memorandum states plainly, "Without early warning, this day would have broken us." The statement reflects operational reality rather than dramatic flourish. 927 sorties launched. 842 directed interceptions attempted. Contact achieved in 761 cases. The ratios demonstrate system effectiveness under maximum stress. Without radar warning, standing patrols would have consumed fuel with 30% contact rate. With radar warning, directed interceptions achieve 82% contact rate. The multiplication effect determines outcome. Germany increases sortie rates expecting collapse. The opposite occurs. Early warning plus sector control preserves RAF strength despite repeated airfield strikes. Ground crews restore operations overnight. Squadrons return to readiness by dawn. Damage proves temporary. Capability persists. Luftwaffe formations suffer mounting crew fatigue. Forward bases in France operate above planned capacity. Maintenance falls behind due to battle damage accumulation. Spare parts stockpiles deplete. Fuel consumption exceeds resupply rate. Serviceability rates declined from 90% to 75% within 2 weeks of sustained operations. Fighter Command maintains serviceability through planned logistics. Repair depots operate 3 shifts. Replacement engines arrive from shadow factories. Ammunition production meets expenditure. Fuel reserves remain adequate. Statistical control identifies bottlenecks before they become critical shortages. The mass effort validates the system's endurance rather than revealing its breaking point. Britain proves resilience through organization, not luck or heroism alone. Redundancy sustains function when single points of failure would break an improvised system. Rotation preserves effectiveness when endurance competition would exhaust resources. Measurement enables adjustment when intuition would guess incorrectly. 18th of August becomes known in historical accounts as the hardest day for Germany. The day marks failure of attrition strategy. For Britain, the day confirms the Dowding system functions under sustained maximum assault. Both conclusions derive from the same evidence. Loss parity when Germany needs decisive advantage. The coastal towers still transmit. The operations rooms still plot. The fighters still intercept. And the calendar advances toward September without German air superiority achieved. A controller's pencil marks notation on the glass plotting table at Uxbridge Operations Room. Civil target, London plot stream inland from the coastal radar stations. Multiple formations converging on a single objective. Air raid sirens carry across the Thames at 1630 hours. The strategic shift begins without ambiguity. Adolf Hitler issues Directive 17 on the 5th of September. Bomb London. Terror raids against civilian population. Retaliation for RAF bomber command strikes on Berlin during late August. The Führer believes Fighter Command defeated. Intelligence estimates place British fighter strength below 200 serviceable aircraft. Göring assures Hitler that air superiority exists. Invasion can proceed. The estimate contains a fatal compounding error. Fighter Command maintains more than 700 serviceable fighters through mid-September. Rotation policy preserves pilot strength despite combat losses. Repair depots restore damaged airframes faster than combat writes them off. Factory production replaces total losses. Pilot training pipeline delivers replacements adequate to maintain squadron strength. The defensive network remains intact. strengthening rather than weakening. Avoiding 11 group airfields spares the radar network and sector infrastructure from sustained attack. The original German operational plan targeted air defense system nodes systematically. Airfields first, operations rooms second, communications hubs third, the towers themselves as opportunity permitted. Switching to civilian bombing abandons that methodical strategy in favor of a politically motivated terror campaign. Kampfgeschwader 55 and 76 lead formations over London starting the 7th of September. Hundreds of bombers in multiple waves. Jagdgeschwader 26 provides fighter escort. Messerschmitt Bf 109 fighters maintain top cover at 25,000 feet. The formations proceed toward London expecting reduced resistance. Intercepts remain above 80% despite target change. Chain home tracks formations from the French coast to Thames estuary. Controllers vector squadrons to intercept bearing and altitude with standard 12-minute warning. Contact achieved before bombs fall in most cases. German formations suffer standing losses throughout September without achieving surprise. September civilian casualties exceed 6,000 in London alone. Fires consume East End docks and warehouses. Residential areas in Stepney, Poplar, and West Ham sustain heavy damage. Underground stations shelter thousands nightly. Civil defense organizations manage rescue and recovery operations. Damage spreads across 23 London boroughs. The human cost mounts daily. But RAF operations continue uninterrupted. The operational respite from airfield attacks allows repair of damaged infrastructure accumulated during August. Sector stations restore communications through permanent cable replacement rather than temporary patches. Runways undergo proper repair with drainage and surface restoration. Squadron rotations proceed according to the peacetime training schedule. Fighter strength increases through September rather than decreasing. A Luftwaffe 2 diary entry dated 18th of September records mounting frustration in bureaucratic language. Feindliche Pfange ungebrochen.
Verluste nicht tragbar, enemy intercepts unbroken.
Losses unsustainable. The admission appears in operational summary rather than tactical report. Command level recognizes the strategic problem. Attrition continues without decision. German bomber losses mount without suppressing defense capability. Formations suffer standing attrition rates above 5% per mission throughout September. Crew replacements lag behind losses despite training pipeline expansion. Experienced pilots transfer to training units, reducing frontline quality. Aircraft availability declines at forward bases from 80% to 60%. Fuel stocks tighten due to sustained high sortie rates exceeding resupply logistics. Maintenance hours per aircraft double as battle damage accumulates. The strategic shift protects the infrastructure that guarantees RAF persistence. By sparing sector stations and radar sites, Germany preserves Britain's operational advantage. The coastal towers remain functional throughout September. The landlines remain connected without disruption. The filter room continues plotting tracks without interruption. The operations room continues directing interceptions according to standard procedure. Post-war operational analysis identifies the switch to London as the decisive German strategic error. Operational logic demanded suppression of air defense networks before attempting any other objective. Systematic destruction of radar sites, sector stations, group headquarters, and communications infrastructure should have preceded terror bombing. Instead, Germany abandons a partially successful attrition strategy for a politically motivated campaign that achieves no military objective. The irony becomes clear through historical hindsight. By sparing the towers, Germany preserves Britain's eyes. The very infrastructure that enables continued resistance remains undamaged through September and October. The system endures without degradation. The defense persists at full effectiveness. Royal Air Force losses during September total approximately 280 aircraft. German losses exceed 600 aircraft. The exchange ratio shifts decisively in Britain's favor. Production replaces British losses. German losses accumulate against finite reserves. Mathematics of attrition reverses. The defender gains strength. The attacker weakens. Night bombing continues through autumn and winter. The Blitz kills thousands of civilians. Property damage reaches hundreds of millions of pounds. But the military objective, suppression of fighter command and achievement of air superiority, remains unaccomplished. Germany bombs cities while the air defense network functions unimpaired. And Operation Sea Lion, the invasion of Britain, never receives an execution order. The precondition, air supremacy, never materializes. German naval staff recognize the impossibility. Wehrmacht planners acknowledge the risk.
Hitler postpones indefinitely.
The switch to London, intended to break British morale and force political capitulation, achieves the opposite strategic effect. Britain survives. The radar network persists. Fighter command strengthens. An invasion becomes impossible. By sparing the towers through target change, Germany hands Britain the one system that makes resistance sustainable. The greatest German strategic error of 1940 occurs not through tactical defeat but through target selection. The coastal towers still transmit. The operations rooms still coordinate. And the fighters still intercept. September ends without German victory. October begins without German hope. Side-by-side schematics appear on a briefing board in the intelligence section at Bentley Priory. British chain home and chain home low diagrams on the left. German Freya and Würzburg schematics on the right. Both nations possess radar technology. Only one nation integrates that technology into comprehensive national defense doctrine. German Freya radar operates at 125 MHz frequency. Wavelength, 2.4 meters. Maximum detection range, 75 kilometers against bomber-sized targets. A rotating antenna mounted on a mobile platform provides bearing accuracy within 2 degrees. Primary application, early warning for anti-aircraft batteries and airfield defense. Secondary application, coastal surveillance against shipping. Würzburg radar operates at 560 MHz frequency. Wavelength, 53 centimeters. Maximum range, 40 kilometers. A 7-meter parabolic reflector enables precise gun laying. Primary application, directing heavy flak batteries against night bombers. The system provides range, bearing, and elevation with accuracy sufficient for predicted barrage fire without visual contact. Both German systems demonstrate capable engineering and operational effectiveness. Frequencies optimized for respective missions through careful analysis. Antenna designs appropriate for required accuracy standards. Power output sufficient for tactical ranges with margin for adverse conditions. Manufacturing quality is excellent based on captured examples examined by British technical intelligence. Reliability high according to German operational records obtained through signals intelligence. The technical gap between British and German radar does not lie in component performance or engineering quality. The gap lies in system architecture, operational doctrine, and command integration philosophy. Both nations solve technical problems. Only Britain solves operational problems. British chain home operates at a lower frequency range, 20 to 30 MHz. Wavelength, 10 to 15 meters.
Fixed antenna mounted on permanent towers.
Limited bearing accuracy, plus or minus 2 degrees. Angular resolution is poor compared to German systems. Maximum range, 120 miles against bomber formations. The advantage, early warning measured in minutes rather than seconds. Tactical warning becomes operational warning. Chain home low fills the altitude coverage gap deliberately. 150 MHz frequency. Rotating antennas on 50-foot towers. Coverage from 500 feet to 15,000 feet altitude. Together, the two systems provide continuous height coverage from ground level to maximum bomber operating altitude. Integration compensates for individual system limitations. Type 7 ground-controlled interception radar entered development during autumn 1940. 10-centimeter wavelength. 3,000 MHz frequency. Mobile platform for deployment flexibility. Precision vectoring capability for night fighter operations. The system will deploy operationally in 1941, adding all-weather interception capability to the network. Royal Air Force average scramble time from radar contact to aircraft wheels up. 7 minutes measured across 11 group sectors during August and September. Directed interceptions reduce wasted patrol hours by 70% compared to standing patrol doctrine. Fuel conservation improves proportionally. Pilot fatigue decreases through elimination of fruitless searching. Squadron endurance increases through reduced operational tempo per engagement. German fighter control averages longer response times throughout the Battle of Britain. Radar provides early warning to airfields and gun batteries, but coordinated interception doctrine remains undeveloped at operational level. Fighters patrol assigned zones rather than receiving precision vectors from ground control. Contact occurs through visual search rather than a ground-controlled approach to specific coordinates. Individual pilot skill determines outcome more than system effectiveness. A Fighter Command technical note dated October 1940 summarizes the fundamental difference in a single sentence. The value lies in the net rather than the node. Germany fields capable individual sensors without nationwide interception doctrine connecting them. Excellent radar sets operate in isolation, serving local commanders without centralized coordination. Britain networks less capable sensors into integrated command structure serving national strategic objectives. Identical physics applied through different operational philosophies. Different systems architecture. Only one approach scales to campaign-level operations. The comparison reveals strategic choices made years before war began. Germany invests in tactical applications. Gun laying for flak batteries, local warning for airfield defense, short-range precision for immediate threats. Britain invests in operational integration. National coverage linking sensors, centralized control coordinating response, standardized procedures enabling coordination across geography. Both approaches demonstrate technical competence and engineering excellence. Only one approach achieves strategic operational effect at campaign scale. The outcome of the Battle of Britain reflects that fundamental choice made during peacetime development. Technology alone determines nothing. Application of technology through doctrine determines everything. Germany possesses radar technology equal to Britain in many respects. Superior in some characteristics. Bearing accuracy, angular resolution, mobility. Britain possesses advantage in integration, network architecture, command coordination, procedural discipline. The integration advantage outweighs technical performance advantage. System effectiveness exceeds sensor capability. The distinction appears obvious through historical hindsight. During 1940, the distinction escaped German understanding. Luftwaffe intelligence analyzes British radar as a collection of independent sensors with limited capability. Missing, recognition of network integration. Missing, understanding of centralized control. Missing, appreciation of system-level multiplication effect. British operational research quantifies the multiplication effect during autumn 1940. Analysis of engagement statistics demonstrates fourfold effectiveness improvement from radar-directed interception compared to visual patrol. One squadron with radar warning equals 4 squadrons without warning in terms of contact probability and fuel efficiency. The multiplication compounds across 30 squadrons in 11 group. Germany develops capable radar technology. Britain develops a capable radar system. Technology versus system. Component versus integration. Sensor versus network. The distinction determines survival during summer and autumn 1940. Radar did not win the Battle of Britain alone. System architecture, operational discipline, and command integration transformed radar from interesting technology into decisive military advantage. The transformation required 5 years of peacetime development, institutional commitment, and doctrinal innovation. When the crisis arrived, the system existed ready for employment. The difference determined survival, and survival determined the course of the war. Winston Churchill stands in the Uxbridge Gallery overlooking 11 Group Operations Room. Below, controllers rotate squadron status tiles on a vertical display board. Colored lights indicate readiness states according to the standard system. Green, squadron available, pilots at dispersal. Red, squadron engaged in combat operations. Black, Squadron landed for refuel and rearm. The lights change continuously throughout the morning. Chain home stations detect first morning formations at 0906 hours. Multiple contacts assembling over Pas-de-Calais and Boulogne. Estimated raid strength. Approximately 250 aircraft based on radar return intensity. Controllers vector squadrons to altitude and bearing with standard 12-minute warning time. Intercept achieved before formations reach Greater London suburbs. The Luftwaffe operational planners expect the morning's maximum effort to open afternoon skies by exhausting British fighter reserves. German intelligence estimates, maintained through September despite contrary evidence, place RAF fighter strength below 300 serviceable aircraft. The estimate proves incorrect by a factor of more than 2. Fighter Command maintains 746 serviceable aircraft across all groups on 15th of September according to daily status returns. Fresh RAF squadrons launch at 1400 hours as second major raid forms over the French coast. Controllers coordinate 11 group and 12 group assets according to prearranged procedure. Squadrons from Biggin Hill Sector, Nordholt Sector, and Hornchurch Sector intercept in coordinated waves. Altitude advantage maintained through early scrambles. Fuel margins sufficient for extended combat. Contact achieved according to operational plan rather than chance encounter. German formations include Kampfgeschwader 1 and 53 bomber units. Jagdgeschwader 26 and 51 provide fighter escort at 3 altitude bands. Messerschmitt Bf 109 fighters maintain top cover at operational ceiling above RAF formations. Supermarine Spitfires and Hawker Hurricanes engage from below and flanks according to standard tactical doctrine. Hurricanes target bombers. Spitfires engage escort fighters. The day ends with recorded losses documented through both sides' operational records. 56 German aircraft destroyed for 26 RAF losses. An asymmetry recorded and confirmed by both British and German sources. German operational claims during combat inflate RAF losses to over 100 aircraft destroyed. British pilot claims inflate German losses to 185 aircraft destroyed. Post-war historical analysis establishes accurate figures through examination of unit records, casualty lists, and aircraft serial number accounting. Air Ministry summary issued 17th of September concludes German offensive strength, temporarily exhausted based on signals intelligence and operational analysis. The assessment proves accurate. Luftwaffe sortie rates decline following 15th of September. Crew fatigue accumulates after weeks of sustained operations. Aircraft availability drops due to maintenance backlog. Forward base logistics strain under sustained operations tempo above peacetime planning assumptions. Churchill delivers remarks to Parliament on the 20th of September. The speech addresses the summer's air battle. Tribute to fighter pilots. Recognition of ground crews. Acknowledgement of civilian suffering. The speech concludes with a phrase that enters the historical record. Never in the field of human conflict was so much owed by so many to so few. The tribute honors fighter pilots specifically. Public recognition focuses on aircrew courage and skill. But the victory depends equally on unseen infrastructure supporting those pilots. Chain home operators plotting contacts around the clock. Women's Auxiliary Air Force personnel updating tracks every 30 seconds. Sector controllers issuing vectors based on radar data. Ground crews refueling and rearming aircraft. Signals personnel maintaining landline communications. Repair crews restoring bomb-damaged facilities. The network functions through collective disciplined effort rather than individual heroism alone. Accurate early warning and economy of force produced the campaign's psychological and operational inflection point on 15th of September. Germany commits maximum available effort expecting breakthrough. Britain responds with measured precision and coordinated defense. The contrast in approach determines outcome more than equipment performance or pilot skill. The 15th of September becomes commemorated in subsequent years as Battle of Britain Day. Annual ceremonies honor the anniversary. Memorial services remember the fallen. Historical accounts identify the date as a turning point. The Luftwaffe never again attempts daylight raids of equivalent strength over Britain. Night bombing continues through autumn and winter. But daylight air superiority, the essential precondition for invasion, remains unachieved through autumn 1940. The crucial victory occurs on plotting tables and telephone lines as much as in cockpits at 20,000 feet. Information advantage, maintained through technical systems and operational discipline, outweighs numerical superiority in aircraft and pilots. Force multiplication through system integration defeats force concentration through mass assembly. The principle demonstrates broader strategic truth. Modern warfare favors integrated systems over isolated capabilities. Coordination multiplies effectiveness. Information enables the economy. Economy enables sustainability. Sustainability enables victory through attrition reversal. Germany possessed more aircraft than Britain at campaign start. Germany possessed more trained pilots. Germany possessed geographic advantage operating from occupied Europe. But Germany lacked an integrated air defense system, lacked centralized control doctrine, lacked information advantage. They lacked a determined outcome. The coastal towers still transmit on the 16th of September. The operations rooms still coordinate according to standard procedure. The fighters still intercept based on radar vectors. And the invasion barges still wait in French and Belgian ports without execution order. 15th of September, 1940. The day information defeated mass. The day system defeated improvisation. The day measurement defeated confidence. The decisive day. Staff officers at Oberkommando der Luftwaffe headquarters collate operational returns from Luftflotte 2 and 3. Missing crews listed by name and rank. Damaged bombers categorized by repair time required. Fuel receipts at forward bases showing declining availability. Teleprinters clatter with lost tallies transmitted from France. The numbers accumulate. The trends clarify. And the conclusions prove unavoidable. Oberkommando der Luftwaffe Intelligence Section estimates RAF serviceable fighters at fewer than 200 aircraft through mid-September. Estimate methodology. Claimed victories by German pilots minus estimated British production plus estimated combat attrition equals remaining strength. The mathematical logic appears sound. The baseline data proves catastrophically incorrect. British Operational Research Section daily returns show 746 serviceable fighters on 15th of September. The discrepancy, factor of 3.7. German estimates rely on pilot claims made during combat stress. British records rely on physical aircraft accounting through daily status reports from maintenance units. Methodology determines accuracy. Accuracy determines strategy. Strategy determines outcome. German pilot casualties exceed earlier operational projections by 30% through September. Combat losses plus accident losses plus fatigue-related groundings compound to unsustainable rates. Replacement training pipeline lags behind requirements. Pre-war training standards were maintained initially. Standards relaxed during August. Further relaxation during September. Experienced crews transfer to training units, reducing frontline unit quality. Squadron average experience declines from 1,000 hours to 600 hours per pilot. Channel Coast fuel and spare parts stocks tighten by 30 to 40% during September. Sustained sortie rates consume logistics faster than supply lines replenish from the Reich interior. Forward bases operate above peacetime design capacity. Grass airfields deteriorate under heavy bomber operations exceeding surface load limits. Turnaround times stretch from 1 hour standard to 3 hours average. Maintenance backlog accumulates. Aircraft availability declines from 85% to 60%. A staff appreciation note circulated on the 20th of September concedes the enemy anticipates approaches with unexpected consistency, indirect acknowledgement of British early warning capability. The note avoids mentioning radar specifically. German intelligence maintains the position that British radar remains primitive equipment with limited military application. Operational reality contradicts intelligence assessment. Operational commanders recognize the contradiction privately. Officially, doctrine remains unchanged. British signals intelligence decrypts Luftwaffe communications continuously through government code and cipher school operations at Bletchley Park. Enigma decrypts provide insight into German planning cycles, logistic status, and operational intentions. Fighter Command receives strategic warning of major raids hours before launch through ultra-intelligence. The intelligence advantage compounds radar's tactical warning. Strategic plus tactical warning equals comprehensive information superiority. Reichsmarschall Hermann Göring convenes multiple conferences with unit commanders during mid-September. Demands increased sortie rates despite declining aircraft availability. Questions aircrew victory claims without direct accusation. Orders investigation of intelligence estimates regarding British strength. The conferences produce recrimination without solution. Göring faces an impossible operational equation. Casualties mount while target capability persists. Contemporary German pilot accounts, recorded in unit diaries and personal memoirs, note timely RAF interceptions with increasing frequency. Diary entries reference immediate British response upon crossing coast and unexpected fighter concentrations at altitude. Some experienced cruise suspect advanced warning systems beyond visual observer capability. Official doctrine dismisses the speculation as defeatism. Abwehr intelligence maintains British radar remains primitive technology unsuitable for tactical air defense application. Confidence erodes throughout Luftwaffe command structure during late September. Not through dramatic reversal or catastrophic defeat. Through steady accumulation of negative operational trends. Loss rates per mission increase from 3% in July to 5% in September. Replacement rates cannot match attrition despite an expanded training pipeline. Aircraft serviceability declines 20% at forward bases from July baseline. Mission-capable bomber strength falls below 1,200 aircraft from peak 1,500 in August. Fighter Command, by operational contrast, increases strength throughout September. Daily aircraft production exceeds combat losses by a comfortable margin. Repair depots restore damaged aircraft faster than combat writes them off through modular repair techniques. Pilot training pipelines deliver replacements ahead of attrition through Commonwealth training programs. Sector stations rotate squadrons to preserve effectiveness without exhausting individual units. Statistical control identifies problems before they become critical shortages. The numbers tell an unambiguous story visible to anyone examining operational returns objectively. Germany expected a 4-week decisive campaign. 12 weeks pass by mid-September. Fighter Command remains operational at increasing strength. Coastal radar defenses remain intact and functional. Airfields sustain damage but undergo rapid repair. Squadrons maintain establishment strength through replacement flow. Misestimation of enemy strength plus failure to suppress early warning networks yields rising loss rates without decisive effect on RAF infrastructure or command capability. The campaign's strategic foundation collapses under accumulated weight of contradictory evidence. Initial assumptions proven false. Revised assumptions equally false. Reality persists regardless of assessment. Göring cannot reverse arithmetic through conferences or directives. The Luftwaffe committed to attritional strategy without accurate baseline data regarding enemy strength. When attrition mathematically favors defenders, attacking force loses by definition regardless of tactics or leadership. Germany faces that mathematical certainty through September 1940 without recognition or adaptation. Confidence erodes, not through a single dramatic defeat, through steady accumulation of negative trends visible in daily operational returns. Loss rates, sortie rates, serviceability rates, replacement rates. Every metric trends negatively for Germany. Every metric trends positively for Britain. Mathematics determines outcome independent of courage or skill. And the mathematics conclude, Fighter Command survives. Fighter Command strengthens. An invasion becomes impossible. The Kriegsmarine War Diary records single-line entry in standard bureaucratic format. Operation Sea Lion postponed indefinitely per Führer directive. The cross-channel invasion, planned in detail since July 1940, requires air superiority as absolute precondition. Kriegsmarine Naval Staff calculates invasion fleet survivability against RAF Bomber Command and Royal Navy coastal forces operating without Luftwaffe air cover. Conclusion: unacceptable loss probability. Without Luftwaffe control of airspace over channel and landing beaches, amphibious operation becomes militarily impossible regardless of ground force quality or invasion plan sophistication. Adolf Hitler issued a formal directive postponing Operation Sea Lion on 17th of September. No specific resumption date given in directive text. Military operational reality supersedes political ambition and strategic preference. The Wehrmacht General Staff cannot guarantee air cover for vulnerable landing craft during channel crossing. The Kriegsmarine cannot guarantee naval superiority against the Royal Navy without air supremacy. Fighter Command maintains effective control of southern English airspace despite 3 months of sustained Luftwaffe operations. British Cabinet War Room minutes record the intelligence assessments during the 18th of September meeting. Ultra Signals Intelligence decrypts confirm postponement decisions through intercepted Wehrmacht communications. Home forces maintain invasion alert status through October as precaution. Beach obstacles remain in place along the southeast coast. Reserve divisions hold defensive positions. Coastal artillery maintains readiness. But operational intelligence assessment concludes invasion probability declining rapidly. Operation Sea Lion planning documents reveal extraordinary scope of undertaking. 13 divisions in the first assault wave. Amphibious landing from Folkestone to Brighton across a 90-mile front. Airborne drops inland to secure bridges and road networks. Armored advance toward London following beachhead consolidation. The logistics plan requires clear skies and calm seas for a minimum 4 days. Neither meteorological condition guaranteed without air dominance preventing RAF interdiction. German naval staff recognizes operational impossibility without air supremacy through cold mathematical analysis. Kriegsmarine War Diary entry states the conclusion plainly without euphemism. Without air supremacy over channel and landing areas, amphibious landing operationally impossible regardless of ground force preparation. The campaign's cumulative loss summaries tell quantitative stories without ambiguity. Through 31st of October 1940, Luftwaffe total losses. Approximately 1,733 aircraft destroyed or damaged beyond repair. Aircrew casualties exceed 3,500 killed, missing, or captured. Royal Air Force total losses in the same period. 915 aircraft destroyed and 537 pilots killed or missing. The loss ratios demonstrate defensive advantage throughout the campaign. Britain replaces losses through domestic production and Commonwealth support. Germany cannot sustain a loss rate against finite industrial capacity and trained personnel reserves. British fighter production exceeded German production by August 1940. Pilot training pipelines favor defenders operating over home territory with rescue and recovery advantage. The arithmetic of attrition consistently favors Britain throughout summer and autumn. Chain-home radar network contributes decisively to operational outcome through information advantage enabling economy of force. Early warning enables fighter direction to intercept rather than standing patrol consumption of resources. Controllers direct limited fighter strength to specific threats rather than dispersing across potential approach vectors. Fuel conservation through direct routing. Reduced pilot fatigue through elimination of fruitless searching. Higher sortie rates from available aircraft through time-on-target optimization. The multiplication effect appears clearly in engagement statistics. Post-war operational analysis calculates fourfold productivity improvement from radar-directed interception. 1 RAF squadron with chain-home early warning equals 4 squadrons on standing patrol without warning in terms of contact probability and resource efficiency. The multiplication effect compounds across 33 squadrons in 11 group. Effective strength, 132 squadron equivalents from organizational and technical advantage. British information advantage, radar detection to filter room track correlation to operations room control to sector direction to squadron interception, denies Germany control of air. Air control determines control of channel waters. Channel control determines invasion operation viability. The causal chain runs directly through chain-home infrastructure and doubting system integration. The 17th of September marks the operational conclusion of the invasion threat. Night bombing campaign continues through spring 1941. The Blitz killed 43,000 civilians through May 1941. Strategic bombing damages ports, factories, and transportation infrastructure. But the strategic objective, cross-channel invasion of Britain, remains permanently unachieved. Germany cannot land forces, cannot reinforce beachhead, cannot sustain logistics across contested waters. The Wehrmacht necessarily turns strategic attention eastward toward the Soviet Union. The largest amphibious operation planned in Europe to that date ends on radar plot and statistical analysis rather than contested beach landing. Invasion barges assembled in French and Belgian Channel ports remain unused. Troops trained for amphibious assault redeploy to other theaters. Specialized equipment transfers east for Operation Barbarossa planning. The strategic moment passes irrevocably. Britain survives not through miraculous intervention but through systematic preparation over a 5-year period. Radar development began 1935. Network integration development beginning 1936. Operational doctrine refinement beginning 1938. When an existential crisis arrives in summer 1940, the defensive system functions as designed through peacetime planning and preparation. The towers detected formations at 120 miles. The controllers directed squadrons to optimal intercept geometry. The fighters engaged with information advantage. And the invasion never came to British beaches. 17th of September, 1940. The day German strategic ambition confronted British systematic measurement and preparation. Measurement and preparation prevailed. Ambition failed. The principle extends beyond specific campaigns. Prepared defense defeats improvised offense. The system defeats the collection of capabilities. Integration defeats isolation.
Information defeats surprise.
The lessons shape subsequent military development through the remainder of the 20th century. Operation Sea Lion. Cancelled. Britain. Survived. Chain home. Validated. A rotating aerial on a Type 7 ground-controlled interception radar set sweeps the horizon in a smooth mechanical arc 10 cm wavelength. 3000 MHz frequency. Mobile platform mounted on truck chassis. Plan position indicator display shows map-like presentation rather than oscilloscope trace. A duty log records V1 flying bomb bearings and speeds with precise notation. The air defense system built for the 1940 Battle of Britain evolves continuously through war years. Static defense becomes an adaptive system. Initial capabilities expand through technical development and operational experience. Chain home network expands from 20 stations at war outbreak to over 150 fixed stations by 1944. Chain home low supplements high-altitude coverage with dedicated low-altitude detection from 500 feet to 15,000 feet. Mobile radar sets deploy to forward locations and overseas theaters. Technology developed for home defense exports globally. Staffing increases from hundreds of personnel at war outbreak to tens of thousands by war end. Women's auxiliary Air Force personnel operate radar stations across Britain in all technical roles. Radar mechanics, designated fitters in service terminology, maintain equipment operational reliability above 90% through war years. Royal Air Force Signals Branch personnel string thousands of miles of landline communications connecting stations to control centers. The network transforms from an experimental system to essential national infrastructure. Technical improvements compound incrementally throughout war. Higher transmitter power output improves detection range and target discrimination. Better receiver sensitivity enables detection of smaller targets at greater distance. Improved cathode ray display tubes provide clearer presentation for operators. Plan position indicator displays replace original A-scope amplitude traces during 1943. Operators observe map-like rotating displays rather than interpreting deflection graphs. Target identification and tracking accuracy improves dramatically. The identification friend or foe transponder system integrates with radar during 1942. Friendly aircraft carry transponders that respond to radar interrogation with coded signals. Operators distinguish friendly from hostile aircraft automatically rather than relying on flight plan correlation. False identification rates drop from 15% to below 2%. Engagement errors decrease proportionally. Night fighter operations integrate Type 7 ground-controlled interception control during 1941. Ground controllers vector night fighters to within visual range of targets using precision radar tracking. Airborne interception radar mounted in fighter aircraft completes engagement sequence. Bristol Beaufighter and de Havilland Mosquito night fighters carry AI Mark IV and later AI Mark X radar. The combination achieves interception rates above 60% against night raiders by 1943 compared to below 10% during 1940 without airborne radar. V-1 Flying Bomb Campaign Summer 1944 tests the evolved integrated system comprehensively. Fieseler Fi-103 cruise missiles, designated V-1 by British intelligence, target London from launch sites in Pas-de-Calais. Small radar cross-section challenges detection. High speed, 400 miles per hour, reduces engagement time. Low altitude, below 3,000 feet, exploits radar coverage gaps. Chain home and chain home low detect V-1 launches from the French coast. Controllers coordinate 3 defensive layers. Fighters in channel, anti-aircraft guns on coast, barrage balloons over London. Fighter pilots develop high-speed diving attacks intercepting missiles before coast. Anti-aircraft gunners employ radar-directed predicted fire. Coordination improves through operational experience. Interception rate rises from 40% first week to above 80% by campaign end. System integration defeats technical challenges through coordinated adaptation. A Fighter Command operational note remarks during autumn 1944, "Our most reliable pilot remains the cathode ray tube. The metaphor reflects operational reality without exaggeration. Electronic instruments guide interception more reliably than human vision under most operational conditions. Technology augments human capability. Human operators direct technology. Integration produces capability neither possesses independently." The post-war transition begins at 1945. The Royal Air Force maintains radar stations for air traffic control and continuing air defense missions. Chain home stations decommission gradually through the late 1940s as newer technology replaces wartime systems. Some stations convert to civilian air traffic control. Others close permanently. Physical infrastructure is dismantled. Operational principles endure. The system architecture developed 1935 through 1940 became the foundation for all subsequent air defense systems globally. Centralized control doctrine, integrated sensor networks, coordinated response procedures, standardized communications protocols, real-time data fusion. The principles established at Bentley Priory shape air defense organization through the remainder of the century. Cold War early warning lines follow the chain home organizational model directly. Distant early warning line across Arctic Canada detects Soviet bomber approach. Ballistic missile early warning system in Greenland, Alaska, and England detects intercontinental ballistic missile launches. The semi-automatic ground environment in continental United States integrates hundreds of radar stations into a centralized computer-controlled network. All systems descend directly from Doubting System architecture developed for the Battle of Britain. NATO air defense integrated national networks into alliance-wide structure during the 1950s. Standardized data link systems transmit track information between allied nations. Common procedures enable multinational coordination. Fighter aircraft from multiple nations operate under integrated control. The concept traces directly to Bentley Priory filter room operations of 1940, where multiple information sources fused into a single operational picture. Modern civil air traffic control employs identical operational principles worldwide. Multiple radar sites provide overlapping coverage. Central coordination eliminates conflicting clearances. Standardized procedures enable international operations. Real-time data sharing between facilities. Chain home pioneered civilian applications adopted universally in post-war aviation. The wartime network became the blueprint for global air defense architecture and foundation for modern air traffic management. Core technologies change completely. Vacuum tubes become transistors and integrated circuits. Analog displays become digital computers and become software systems. But fundamental principles remain constant across 80 years. Detection through sensors, integration through networks, control through centralized coordination, response through standardized procedures. From the experimental shed at Daventry February 1935 to global air defense and air traffic control infrastructure in the 21st century. Continuous evolution, unbroken lineage, enduring principles. A post-war statistical review document lies open on a polished wood desk at the Air Ministry. Columns record costs in pounds sterling, losses in aircraft and personnel, outputs in sorties and interceptions. Graphs plot trends across campaign months. Tables compare planned versus actual expenditures. A pencil rests in margin, having underlined key summary totals. The numbers tell a complete story without interpretation required. Cabinet Office Statistical Analysis Branch conducts comprehensive assessment of air defense effectiveness during winter 1945 through 1946. Detailed cost-benefit analysis. Chain home development costs. Approximately £10 million sterling across 5-year period from initial research through operational deployment. Less than 2% of total defense budget in the same period. German aircraft losses attributed directly or indirectly to fighter command operations. Approximately 1,700 aircraft destroyed through combat and operational accidents during the Battle of Britain period. Wartime replacement value at 1940 prices. Orders of magnitude higher than defensive system cost. Pre-war critics expected radar development to consume resources without proportional military value. The Treasury questioned expenditure during budget reviews 1936 through 1939. Some military officers preferred investment in additional fighter squadrons rather than experimental detection equipment. The post-war review conclusively demonstrates the opposite conclusion. Cost per German aircraft destroyed approximately £6,000, including all development costs, deployment expenses, and operational expenditures. Direct comparison. Cost of single Heinkel HE-111 bomber at 1940 production values £30,000. Exchange ratio favors defense decisively across all metrics examined. Air Staff post-war operational appreciations calculate force multiplication effect from radar-directed air defense. Chain home network multiplies fighter effectiveness by an estimated factor of 4 compared to pre-radar standing patrol doctrine. 1 fighter squadron with radar early warning equals 4 squadrons on visual patrol without warning in terms of contact probability, fuel efficiency, and pilot fatigue management. Fuel consumption reduced by approximately 70% per successful interception. Pilot fatigue reduced proportionally through elimination of fruitless patrol hours. Aircraft utilization increased 40% through more efficient mission planning. The summer and autumn 1940 campaign proves information multiplies force effectiveness across all operational domains. 915 RAF aircraft lost produced strategic defensive victory. 1,733 Luftwaffe aircraft lost produces strategic offensive defeat. Similar loss totals. Opposite strategic outcomes. The difference. Information advantage maintained through technical system integration and operational discipline. Air Chief Marshal Sir Hugh Dowding submits a final memorandum on air defense lessons learned to the Air Ministry during spring 1946. The assessment emphasizes victory through organization and foresight rather than luck or exceptional heroism alone. Individual courage remains an absolutely essential component of success. Pilots demonstrate extraordinary bravery daily throughout the campaign. But courage without supporting system infrastructure produces only martyrdom rather than victory. A system without courageous operators produces only theoretical capability rather than operational results. Integration of human courage with systematic organization achieves sustainable defense. The memorandum circulates through Allied air forces during 1946 and 1947. The United States Army Air Forces adopts integrated air defense doctrine based directly on British experience. Soviet air defense forces develop centralized control systems following similar principles. Post-war air forces universally accept radar-guided interception as standard practice, replacing visual patrol doctrine. French, Dutch, Belgian, Canadian, Australian air forces all implement chain-home organizational principles adapted to national requirements. Britain demonstrates operationally during 1940 what becomes accepted military axiom by 1945. Modern air warfare requires integrated sensor networks, centralized command control, and coordinated response procedures. Individual aircraft performance characteristics matter significantly less than overall system effectiveness. Numerical strength in aircraft and pilots matters less than information advantage enabling force multiplication. Organization defeats improvisation. Measurement defeats intuition. The system defeats the collection of isolated capabilities. Chain home proves definitively that properly networked sensors, disciplined command control, and measured logistics defeat numerically superior adversaries. The operational principle extends far beyond air defense application. Naval warfare incorporates radar integration 1941 through 1945. Ground warfare adopts similar principles for artillery direction and armored operations coordination. Intelligence operations increasingly emphasize systematic collection and analysis over opportunistic acquisition. System integration multiplies effectiveness across all military domains. The final assessment document concludes with a clear declarative statement. Britain maintained control of airspace over home territory during summer and autumn 1940 not through miraculous intervention or exceptional luck, but through systematic measurement, disciplined organization, and sustained preparation. 5 years radar technology development beginning February 1935. 4 years of network integration planning and implementation. 2 years operational doctrine refinement through exercises and training. When the existential crisis arrived in the summer 1940, defensive preparation proved sufficient because preparation was systematic rather than improvised. The physical coastal towers stand down progressively through the late 1940s. Some sites dismantle completely, steel structures cut for scrap. Some convert to civil aviation navigation aids. Some are preserved as historical monuments. Bawdsey Manor returns to private ownership. Bentley Priory continues as a Royal Air Force station. Physical infrastructure fades from operational service. Institutional legacy endures permanently. In 1940, Britain transformed fundamental physics into operational strategy. Detection capability into defensive systems. Information advantage into campaign victory. The transformation required institutional commitment, technical development, operational innovation, and disciplined execution. Preparation over years. Validation over months. Legacy across decades. From Daventry Experimental Shed February 1935 to Global Air Defense Doctrine shaping military operations through the 21st century. 15 years initial development. 80 years of continuing influence. One unbroken achievement sequence. Britain maintained control of home airspace summer and autumn 1940 not by miracle, not by luck, not solely by courage, but by measurement. Systematic measurement. Disciplined measurement. Sustained measurement. The coastal towers detected approaching threats at electromagnetic wavelengths. The filter rooms correlated multiple sensor reports into verified tracks. The operations rooms directed limited fighter resources to optimal intercept geometry. The squadrons engaged with information advantage. And Britain survived. The numbers prove the conclusion. The statistics validate the method. The outcome demonstrates the principle. Britain held the skies in 1940 not by miracle, but by measurement. What is your perspective on this part of history? Share your thoughts in the comments, because every memory and reflection helps keep the past alive.